slightly later than planned. Just would like to welcome Aaron from Leiden University Medical Center, and also representing today the 4D Picture Project. So Aaron, you're going to talk about clinical NLP and the 4D Picture Project. Away you go.
Okay, thanks, Paul, for the invitation. Actually, it's I think coincidence because when I was organizing Manchester NLP Club, every week, 15 minutes before the club, it is an alarm test in the Kilburn building. So maybe Manchester is learning from Lancaster. Okay, so today I'll present some work that I did with some teams in Manchester, and also start from here in Leiden. That I moved here last year in October. I was in Manchester NLP group for 2.5 years before move here. And both in Manchester and Leiden, I joined the project called the clinical NLP. This topic, let's say, is about how to apply natural language processing techniques into clinical settings with patient data to support healthcare. And we were trying to do something like NLP for social good. So during the talk, you can ask a question or give command anytime. Just shout out, or raise your hand. So I start with ChatGPT. Then we go to the clinical NLP tasks, what we can do, and I will introduce the 4D picture that Paul is the chair of work package 3, clinical and NLP part. And then what we did with some examples. Actually, before I start, I would like to have a little survey. How many of you are from NLP background? Okay. Okay. For online people, I cannot see your hands. Okay, I assume there are some people not from NLP backgrounds. So the intro part of ChatGPT might be interesting before the NLP section, especially from 4D picture colleagues. So let's see, what is ChatGPT that is getting popular now? When I asked, read a poem with the topic of Dutch winter, because I came here, it wrote something, and I highlighted in the poem, North Sea, canals, windmills, cyclists, stroopwafels. These are all Dutch stuff, actually. And then I asked, can you read the poem with Lancaster winter? Then it wrote one. And it not only wrote one, but also can translate into Chinese. Look like a very poem-ish Chinese writing. I skipped the English one first because you will see later why. Then I asked, can you highlight what real entity in English poem appear in Lancaster, e.g. Location name, culture, event, etc.? Is that a great question? Because it does know it's the NLP people asking, right? Then he said he or she, let's say they, right, is writing Lancaster in Pennsylvania instead of what I wanted. That's ambiguity part that NLP people know this term very familiar, right? So we give some more instruction guide. Can you write a poem with the topic Lancaster in the UK, not the USA? Then it says, sure, here's a poem about Lancaster, UK, rich history, medieval charm, and connection to the river Luna. Actually, it wrote something. I read it a few times. If anyone want to read it later or now, Paul, would you like to read some?
I'm really not a poet.
Okay.
You go for it.
Okay, so I highlighted the marketplace. I think maybe you go or not, but this is in Lancaster, and this river, and the castle, the famous inn, and the students here, I think from Lancaster University, some of you guys, they mentioned also, the battles, trials with history. So actually, it's pretty making some sense, right? So here it also lists some notes why it wrote in the poem. And by the way, you can get the PPT slides later. You can read it for lullaby or something if you have kids at home. This is like interpretability, I call it, how you interpret the AI model, right? Why the poem come up like this? Because it take into account with some event or place names. Then we want to know, so what is ChatGPT? And it is chat version of generative pre-trained transformer. By the way, this transformer is my nephew's favorite. He's 8 years old now. But of course, ChatGPT was using a different one that's called Attention is All You Need. It come up in Europe's conference in 2017. So here for NLP people, you will be very familiar with it, but let me go through it very briefly. So in Transformer, there is a encoder and decoder. It was initially designed for machine translation. That was my PhD topic about transformer to translate English, Chinese, English, German. And so in this paper, they applied to English to German and English to French data. And when they did the translation, here input is the source, output is the target language, for example, English, French, or English, German. These building blocks in the encoder and decoder, they are one exactly same, multi-head attention, feed-forward networks, multi-head attention, and feed-forward. The only difference in the decoder part, there's a mask-head attention because the generation purpose. So at that time, we tested the transformer of machine translate for machine translation purpose. So I gave some slangs like she was 96 years old and she kicks buckets. Or I give some context like she kicks buckets at 96 years old and her family were sad about her death. So even though people give this context, they translate very literally that this older person literally kicked the bucket instead of passed away. So that is, even though people say transformer is powerful, but this, when we use it for translation, it's still very stupid. It cannot capture the context information that you give it for disambiguity, for disambiguation purpose. Another literal translation example is, for example, here, little things tend to anger my mother, so I feel like I have to walk on eggs whenever I'm at her house. When it translates to Chinese, it's translated literally walking on eggs. So Chinese people will be confused what is mean when you go to your mom's house, you literally walk on eggs, unless there are too many chicken and eggs, right? So transformer difference is the attention part. It starts from, so in the history of machine learning, there's convolution, right? There is a fully connected layer, the local attention, and transformer introduced global attention. And for global attention, you can see the color here very different, right? Because you can assign different weight. Here the color is same because the weight are same. So in transformer, you can give words, specific words or phrases, higher attention if it's important to process your data for translation or whatever application purpose. And then what I want to mention is, so what is attention? Attention before transformer, actually, it was already introduced in 2014 and 2015 when people tried to do machine translation again at that time. Bidirectional recurrent neural networks, they designed, align, and translate together. So actually attention there is more like a word alignment. So which word is more aligned to another one, like you probably aligned to I instead of you from Spanish to English, for example. So attention was introduced at that time for word alignment to build up bilingual connections between languages. And this all happened because in 2013, there's word-to-vector introduced by researchers who went to Google, I think now. So word-to-vector is a revolutionary thing in natural language processing because before the vector form of word representations, we were all doing natural language processing on symbolic words and phrases. But So anyone know this paper of word to vector? Can you raise your hand? In 2013? Okay, most of you. And okay, that's the inconvenience of the online. I cannot do any survey. Anyway, so word to vector, and the brief idea is the vector representation need to mimic the words space lexical distribution. For example, women and men can be opposites in semantics, and in the vector representation, they should all be far away, the distance. And the women and the queen, they are closer. So in the vector representation, their distance should be also closer, should be closer. So one of the example in the paper the author used is queen minus woman plus man in the vector representation is very close to king, the vector value or the distribution. So that's the introduction. And here's the timeline of language models, let's say, or large language models. You can see there are LSTM before transformer, and then we have BERT, we have GPT-3, 3.5, now we have Llama, everyone using. And in this timeline, one of the most important one, or very important one, if not the most, is the BERT model. BERT model actually is only the encoder part of transformer. So transformer we saw a few minutes ago, it has encoder and decoder because it was introduced for machine translation purpose. It's like we have to encode the text, then decode text to another one, right? And for BERT, it takes the encoder of transformer and throw out of the decoder to say, like, I don't want to do translation. I can do other task. I want to do language understanding. I want to do relation extraction. I want to do name entity recognition. I don't want to do translation. Then we don't need a decoder. So this we saw the encoder part actually for specific application purpose, we add the adaptation layer after the encoder learning of word representation and the relations and semantic distributions. You add the adaptation layer. It's like on top of transformer's height, you think about what I want to do or what I can do. So far, any questions about from ChatGPT to, okay, then I continue, okay? So for clinical NLP, what we can do in the clinical setting, there is a clinical NLP workshop. Last year was with NACO for 6th edition, so this year will be 7th year already. And here is a GitHub link of University of Manchester Healthcare Text Analytics with some open source tools that we developed about the temporal relations, machine translation, clinical text, and for more, so people can check it out. So in clinical setting, I list a few items that you can think about. For example, medication mining, relation modeling. For example, if we drop a personal electronic health record history, if this person is 60 years old, he or she might have visited the doctor very frequently, might not, but in general, this person might have a bunch of letters. One of the direct application is, can you extract all the medications that has been used for this person's healthcare treatments history? So if you read the letters, if you can, right? Like normally we do in the history, the clinician read one by one. But if there are a bunch of letters or if there are a lot of letters, firstly, the clinician might read the whole afternoon to understand this patient history. But if you have a very good tool to extract this medication with a good confidence level, then the clinician can understand the situation very straightforward. Even you can generate the graph after extraction. So like very visually, they can understand, okay, what was used for this patient and or what the symptom was the cause that to give this kind of treatment or how it was progressed. So this kind of medication related event mining can be very useful for efficiency of treatment. For example, in UK, many patients were in the queue to wait to see the hospitals or GPs very long because there's shortage of GP, but there's also this a lot of patients, they want to see GP, but they cannot see because this system might be not efficient, like people complained. And then other things we can do using for clinical NLP, including, for example, for ethical issues, because patient data are sensitive, so it's not easy to share even after the de-identification or anonymization. So can we use a large language model to generate some clinically sound text to train models for the healthcare purpose? Because we want to use NLP to support patient healthcare, but without data, the NLP model does not work. But to access data, there are a lot of barriers. For example, in UK, it's very, very hard to share patient data after you anonymize it. Even after you anonymize it, it has to be there in a data lake hosted by hospital, for example. Not every researchers can use it. If a researcher cannot use it, they cannot develop such models, right? Compared to this, actually in the USA, they have different policy. They have a N2C2 shared task called the clinical NLP shared task organized since 2003-ish. So they have a policy. It's like there are, for example, 20 or 13 items. If you mark all these items out from the patient data, you can share it. So they mark it very carefully, go through all these requirements, then they can share this data. Then people can use it. And of course, everything have pros and cons. In the UK setting, it's more secure and more conscious, or let's say, whatever way. But it is some barrier for researchers to use it. But in the USA, researcher can be easily access the anonymized one, the de-identified one, but there might be some risk, right? Like even for fully anonymized letter, if it's a rare disease or rare symptoms, it might be able to trace back this patient. For example, the whole state has 5 people of this problem, right? And it might be traced back. Of course, this item might be in their list. I'm not quite sure, but there is a risk. So to deal with this, one of the growing topic nowadays is, well, people use Llama, people use ChatGPT, actually generative model, a decoder model. So can we generate synthetic data that has clinical soundness to train model? So we won't use it for healthcare, but without really accessing real patient data. So that's the one topic. And another topic people can do is about the public health literacy, because so how lay people, like most of NLP people can be lay people in healthcare, right? So how our lay people can receive what level of healthcare understanding affect how you benefit the healthcare system. So for biomedical document, most of us, we don't understand at all because there are a lot of terminologies, and the clinicians use a very specific way to write it. So one way is, can we do the text simplification or lay language adaptation of healthcare documents, biomedical data that is totally public online and free access? Just people don't understand. That's a shame, right? So there are shared tasks called the PLABA, that is plain language adaptation of biomedical abstract. They organize the training data and test data. People submit their system. And from this year, there's a new shared task called the perspective-aware healthcare answer summarization. So the difference with PLABA is like biomedical academic rating, right? And then there is an online forum about the healthcare, for example, diabetes patients, or other kind of specific problem forum focused on healthcare. And a lot of people talk there, but generate a lot of data. It will cost a while to understand what is going on. So can we use NLP to summarize what is the problem, what is question, what is the answer, and how to easily understand this a summary of this whole, for example, 20 pages discussions, right? And then other thing we can use is the combination of natural language processing and knowledge graphs. So in clinical setting, a lot of at least a few for terminologies people use. For example, summarisation, their international, their UK version, their ULMS that clinicians use to maintain the hierarchy of clinical, let's say, drugs, their usage, symptoms, all these relations and entities. And can we use this kind of knowledge graph, like call it, it's knowledge, it's a graph format, right? With NLP tools for the better of digitalization, because before NLP get popular, after a patient sees the doctor, the doctors actually hire human coders to code the drugs they use to this database, for example, Stomacity. And these human coders can also introduce error because the database is not that clean, and it costs time and costs money-wise as well. So there are people, there are researchers doing automatic coding or linking in natural language processing. We call it name entity linking. Actually, it's similar task or same task. So that's another thing we can do. And then when I was in Manchester, I was aware that in King's College, they are also doing predictions. So if a patient have this problem, having this treatment, what will be the next step? Of course, they have a restricted setting, so reduce the risk. So you cannot just use these predictions for patient really healthcare usage, but it's like they were demonstrating some of their research outcomes. So, but in the long term, let's say 5-10 years ish, can we use NLP tools to assist the patient's diagnosis or predictions? And if the model have a high confidence, that is good, right? So you don't have to see this specialist, but use some models to easily access, but give you trustworthy prediction of your next state, what you will be. And if you probably will have next stage of something, is there any earlier interventions you can take to delay this problem development, right? Also for this prediction part in many lower, how to call it, low resource country or lack of some professional doctors, it will be really useful to help some people in daily life, like what they can receive. That's, let's say, they could have received better medical instruction from professionals, but they don't have much access. With language model, you can receive like 80% what the professional will tell you. That will be better than nothing for undeveloped countries or areas. And yeah, these some examples. So this is a diagram that I draw that was funded by Open Research Fund. We can apply multitask learning for clinical input. You can do entity labeling like medical events, relation extraction like medical treatment and problems and outcomes. And linking is, for example, the drugs you used. For safe drug usage, they have some regulatory regulations linked to stomacity, blah, blah. So this can be all connected using multitask learning. And here is if we use GPT-ish decoders, if we generate synthetic data, we can do similar temporal relation extraction and all these clinical events we mentioned, and post-process to fire, that is one clinical knowledge base, and stomacity is another one. And then, okay, now any questions? No? Okay, is it very clear or I talking very stupid? Okay. If no question, I'll continue for the Friday. By the way, Paul, how long is the session?
Well, that's kind of why I was holding back from asking questions. So You should probably try and finish in 20 minutes, including questions.
Okay.
So we need to finish at 10:02.
Okay.
Yeah, so it depends how many slides you've got left. We can ask some questions now if you want us to use some time.
Okay, I'll wait for 30 seconds, see if people ask questions.
I had a particular question that I can ask at this point. You mentioned briefly the synthetic data a couple of slides back.
Yeah.
So do you think that's a real kind of suitable and good alternative if there is not enough or any data available for real kind of language analysis
Yes.
in this domain? I mean, is it a good alternative? Is it a suitable, useful thing to do?
The answer is yes and no. So yes is we actually are using some of the synthetic data we generate to train name entity recognition model. For example, specifically extract the drugs or learn what is drug. If you drop a bunch of letters, we can extract a very almost 98 or 99% accurate. All the drugs can be extracted under the dosage and the routes. That is yes, and I will mention the paper later in the examples with students from Manchester. And then no is at the moment we cannot make the clinical soundness, or we haven't evaluated the clinical soundness. So in the paper we published, we specifically wrote in the limitation section. So for the task we applied is NER, name entity recognition, but not train junior clinicians, because we did not evaluate the clinical correctness of the generated data. But that's really good question. It also leads to many future works how to make the clinical soundness of generated letters.
Yeah. Okay. Any other questions in the room or online? I think we're waiting for your next slides.
Okay, so I go next, the 4D that connects me, Paul, and many colleagues. So what is 4D? The 4D picture is a European Union funded project. If I'm not wrong, please correct me, Paul, by European Research Council. So the aim of the project is to support the cancer patients, their families, and the healthcare providers for better understanding their options. And under 4D, of course, there are clinicians, there are professionals, there are HR, there are many people, more than 100 hired people. And it is across multiple countries, including UK, Netherlands, that I'm in and was in. And under 4D, we have different work packages. And for work package 3, I think Paul is the lead. Maybe he knows better than me, but let's say. So for some idea for work package 3, that is text mining part. What I want to contribute is language-specific models, for example, adapt to Dutch, and the domain-specific models, like say, adapt to cancer, not only general electronic health records, right? And then what we still continue need to do can be done is medication treatment effect, this kind of event mining and their relations, extraction of this, and put also temporal temporality layer, let's say, and the knowledge graph construction of extracted entities. So after we extract these entities, if we can make the correct relation, we can build a graph. The relation part is challenging because, for example, in one electronic health record letter, this patient may have 2 or 3 symptoms, right? Problem, not only single one, especially people getting older or even younger people with air pollution. So there are different treatments, there are different problems. How can you build the correct relation, right? That's the challenging part. But if you can do it, then we can build a knowledge graph. Like when you watch the movie of Star Wars, they bring out a virtual ball, right? They turn around. Okay, you are here, you are in this problem, you will be blah, blah, blah. In 60 years, you'll be died. Something like that, right? You can do something like that, fancy things. But that is risky, but it is doable, at least scientific wise, in the movie. We can do cohort selection using topic modeling. Actually, now I'm supervising a student here doing it. I will mention it. And then for work package 3, we call it the text mining and citizen science. That's the topic listed on the website. You can see data collection, cleaning of corporate, because everything is based on data. That's important. And the NLP tools, machine learning software prototypes, development, that's our goal. Some entity linking that we already saw, or coding, we call it, in clinical domain. Aspect-based sentiment analysis. Sentiment analysis is another topic, but it adapt to a specific domain, we can do something more, right? There's annotation to be done, new version of the metaphor manual. This is something I think Paul has a student presenting next session. And data-wise, what we have, you can see there are a lot of data we can try. Some are Dutch, some are English, some are Danish, including forum data and patient journal books, and questionnaires or interview data. So they are all different format. It's like what we can do with this different type of data, and what different type of data are suitable for what topics. For example, for topic modeling, we might need a lot of data, right? Maybe we can use the patient storytelling with a lot of text and to cluster during this cancer patient journey, what they are happy about, what they are not happy about with the treatment, with lifetime events, and we can extract some key information out of this big data. And the focus at the moment for my side is entity recognition, temporal relation, linking, and sentiment part, let's say. So, questions so far? No? Okay, so that's briefly 4D and work package 3. Paul will tell you more about the work package 3 and underline, not unlearn. So what we have done so far, so medication related attributes mining and coding. We published a few papers in big data, and also this year in CL for Health is coming about exploring the value of pre-trained language models for name entity recognition. So we compare different models. MedMan is extracting medications, and here is a very handy tool people can download on their desktop, either Windows or MacBook. It's a really good interface. Pablo developed it, and I will go. So the style is I listed the paper and then go briefly of the framework. Okay, and we can talk more details underline as well. So for the first one about exploring the value of pre-trained language models, we compared BioBERT, clinical BERT, versus Scratch Learn Transformer. So this is not pre-trained at all, only the framework. We compare the performance after adding adaptation layer, like we mentioned, right? And then we also add the CIF layer and see what's the performance, because, is there a question? No, okay. So the outcome of this paper is that if you have a certain amount of data, actually this pre-trained language model perform similar with fresh trained transformer. So actually very confidential. If you have a in-house data, you train the indoor transformer, it performs similar to public models on certain tasks. That's the light that about the privacy part. People can use indoor trained, not the public one. So that's one of the main highlight. And for second paper about medication mining, we fine-tune Med7, that is tool people use for medication mining, and multilingual Roberta. And after fine-tuning using around 20,000 lines or sentences, it performed much better than the base model. You will see for example, Med7 label RO, that is context. Actually, it is drug and ADE, adverse drug effects, and some reasons. So this plain model cannot do it at all. But after fine-tuning, it does really pretty good job. And we actually share this fine-tuning code and people can use it. And we share the fine-tuned model as well. And for the third one, there is software available. People can download it. We did the ensemble. So there's plain general model and the domain model, biometric domain model. We did two kind of ensemble. We call the stacked ensemble and the voted ensemble. And after ensemble learning, we want to see if the ensemble can boost individual models' performance. For example, A, B, C, D can perform like this way, but after ensemble, they can have a higher level than each of them. That's the contribution of this work. And for this work, we have ensemble, but we also have interface. You can upload a TXT file or PDF file. It will label all the drugs, reasons, routes in mostly correct manner. But the next step is how can we make the relations? And when we upload the document for this tool is powerful because it have like features. For example, you can select the context, how many contact you want to see around this item, right? And you can also download any Hugging Face NER model. It can do a general NER task as well. And that is entity recognition and linking. And for relation modeling, we did something about the temporality. For example, if we drop some letters, we ask the model during the admission and the discharge time, can you tell me what treatment was used, what was not? Because the clinician and the patient can discuss different treatment and potential things, but not all discussed treatment were used in the time frame, right? So temporal wise, we did some work about the relation modeling. Actually, one undergrad student published a ACL paper on this. That is a good outcome for him. Now he's doing PhD in Manchester. This is ongoing work also. So for the first one, medication and temporal relation extraction. So the pipeline is very standard NLP pipeline. We have a feature extraction, including tokenization, POS tagging, parsing, blah, blah. And then we use even rule-based and CIF-based recognition for time expressions recognition. Then we use the Brazilian model for relation extraction. That was a big data conference. And for the ACL one, we compared traditional pre-trained model fine-tuning versus prompting. That is after ChatGPT come out, become popular, and all reviewers asking what is the prompting outcome, right? What is GPT outcome? So we compare fine-tuning versus prompting on temporal relation extraction. And we compare the breadth GPT T5 versus breadth fine-tuning. And there are a lot of tricks in fine-tuning, including soft and manual and soft and mixed templates of prompting. You can find it in the paper. And for synthetic data generation, come back to Paul's question, if the synthetic data is really used. So for the first paper, we published in the synthetic data for machine learning with NeurIPS. We create a new transformer, actually, because we changed some optimization algorithm, so it is also open source on GitHub. And we used this new transformer to generate a dense medical data, medical instruction or prescription. For example, in a clinical letter, the clinician write many things like this patient come here with different problem, blah, blah, and then there's prescription. For example, this drug, this dosage, how frequent. So we just want to generate this part and to train a medication extraction model. And we compare, so when we use it for NER, we compare, use the synthetic data and use real data. You can see, use real data, it get 98% accuracy. Use synthetic data, it get actually 96% accuracy of medication extraction. Not only medication, but also related attributes, for example, route, dosage-ish. So for this specific usage, the generated synthetic data is good enough for NLP purpose, but not the clinical soundness we mentioned in the discussion. And for full letter generation, we have one paper just accepted to CR for health. That is generating annotated synthetic new letters that is anonymized because it's synthetic letter. So for machine translation of clinical data, we also compared, this is published in the Frontier in Digital Health. We compared small model, so S, when we buy clothes, we have S, right? Even XS, and there are XL as well. But extra large language model is costly because server and because computation powers, blah, blah. We want to know how big is the difference between extra large language model and small language model in machine translation for clinical domain. So we fine-tuned a small model. We compare with the very big giant model. And we call it the clinical marine, clinical no language left behind. This was trained on 200 plus languages. This is the best model in WMT. And we did automatic evaluation, human evaluation. However, the human evaluation says this very small model perform much better after fine-tuning than these giant models. That's a very interesting outcome. That's maybe why they published it, because so the reason we think is for the small model, it is trained, it knows, understand the language, but it is doable to be fine-tuned with, let's say, 500K sentences to clinical domain. But for the giant model that already trained by Facebook or other companies, because it's so big, we will need a lot of real clinical data to fine-tune it successfully. And in most cases, we don't have this large enough clinical data. That's why it performed well, but not as good as the smaller model. That is some useful thing for low budget research groups that they can do it, because marine is only 50 million parameter each, not even 100 million, but the big model can be a few billion parameters. And then for patient health literacy or plain language adaptation, we attended the shared task for plain language adaptation biometric abstract. We have published in the IEEE Internal Current and Health Informatics. So here example is, so for this text, it's not the lay people use text. For the right-hand side is what the lay people use text. They will understand the clinical website using the right-hand side text, not the left-hand side. So there's a sentence structure simplification, term simplification, phrase, paraphrase, or synonyms. This is the task of simplification. For example, accurate pharyngitis, tonsillitis, which is kind of blah, 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 can be simpler as a sore throat, right? People understand what is sore throat. And for this, what we use is we trained and fine-tuned T5 BioGPT BART with control mechanism, compare with ChatGPT, that is one-shot prompting. And we compare the model, we do our own human evaluation, and we have the shared task official human evaluation. That's PLABA. And then I want to skip some because I don't want to run out time. This is some confusion metrics. We want to see what is wrong, what is correct in our modeling. And for this year, we actually ranked the first by task 1 and B together in average for the simplification task. You see UM team here using Roberta base. That's also interesting because people use the Gemini GPT-4 that's really large, and we use Roberta base and we got number 1 after fine-tuning. That's prompt we use as well. Okay, perspective where healthcare answer summarization is just accepted that we use the iterative self-prompting. If anyone knows this term, we can talk more. Anyone know this term? Raise hand. Iterative self-prompting, ISP. If not, please read our paper because it's a very advanced prompting technique. I will share it. These examples that the prompt will fix itself. Okay, topic modeling, I'll skip. Using for the data, we will do temporal topic modeling. Okay, that's the last slide.
Okay, you finished?
Yes.
Okay, perfect. We'll give you a round of applause. Thank you very much.
Thank you.
May not hear that through on Teams, but thanks very much, Aaron, for an interesting talk. So we have a couple of minutes for questions. If people have questions online, please raise your hand or pop it in the chat, or you're in the room, you likewise. I'll ask a question if nobody else wants to. Aaron, you talked about the kind of relation extraction and a whole variety of other things as well. In particular, in 4D picture, we have to try and address this task for not just English, but also Dutch, Danish, and Spanish. So what do you think are the chances of achieving similar levels of accuracy for those languages for that task?
That's a very good question. So at the moment, I'm working with undergrad student for his thesis. He's interested in clinical NLP, so actually he's trying as well. So we want to do on Dutch data. We have a data called patient storytelling. That is a cancer patient stories with interviews. We want to compare actually if the Dutch language model can perform as well as the English one on this task. If not, can we use a multilingual model, not Dutch, not English, but a multilingual train, for example, XLM Roberta, that's multilingual trained language model Roberta, if that can perform better than Dutch language. So this is under investigation. We will see the progress with a few months each to see how they perform on different. That's also a problem on NLP. Before people say natural language processing, not the English language processing, right? So people have to do different language models trainings and address some tasks.
Okay, thanks. I'll ask you the question again in a month or two. Yeah. Okay. Any last questions in the room or online? Please raise your hand. Otherwise, I think we should finish with the time. Thanks very much, Aaron, for joining us today online. Great to have you do a presentation about all of those topics, including 4D picture. And next week we have Kiki talking about another aspect of 4D picture to us in the group as well. So more to come next week. Thanks very much, Aaron, and we'll give you another round of applause to finish up. Thank you very much.
Thanks for having me. And welcome to come to Leiden. There is cheese and tulips.
Okay. And maybe other things to eat as well.
Yeah, and windmills.
Yeah.
Okay.
All right. Cheers, everybody. Thanks, Aaron.
See you.